This is Physics.Land. Let me quickly show you around what you can do here. First, you can feel free to dismiss this warning message. And on the top here, top right, you'll see a bunch of settings that we can tweak. And also take a look at our hidden dimensions so that you can see what's going on that we're trying to do. Under our goals, you can also find my contact information. You can give us comments or feedback. Thank you. Settings. So you can change all the things to different units. Right now we're still in beta, so we have just a couple to play around with. Significant figures and also the review level. If we look at the physical constants, so these are a bunch of physical constants that we might need, and we will add a lot more as time goes on. You can change the significant figures here for the entire global setting, just as you would for the setting tab here. And you can change everything to SI. These are all real time using Angular app. If the number has uncertainty, we will tell you the uncertainty. They can be both either in percentages or in absolute values. These C buttons are for copying, so you can copy all this to different, or to the scratch pad that you can use later. So let's copy the speed of light, C. You can see that the last one that you copy is here on the clipboard. Okay, and if you change it to other system, you can do that too. But the value itself, whatever units you use, the basic quantity is still the same. And I'll explain that a bit soon. So now on the scratch pad, you will see the quantities I paste to this clipboard, and I can use them later if I want to. You can change to different units, or change to different views if you want to look at the absolute error or the percentage error, and look at the units. Okay. All right, so now let's take a quick look. Unit conversion is to show you some quick, easy way of changing, for example, angles. You can change it to degrees or measures in pi. They will tell you what is the principal angle is, what the reference angle is, and so forth. You can do temperature conversion, so if it is in Kelvin, 5 degree Kelvin, for example, is what is Celsius in Celsius and Fahrenheit. You see that sometimes they tell you some interesting fact about those temperatures. I think 70-some is around the boiling point of liquid nitrogen, for example. Okay, and you can also do any other generic conversion for energy, for example, from joules to kilowatt hours, to other units, to calories. Now, if it's SI unit, you can choose the prefix, kilojoules. So as you change these units and prefix, the actual quantity here will change so that the entire unit, the entire physical quantity is unchanged. So we'll assume the quantity is unchanged and change the values, the numerical values accordingly. So it can be mega and so forth. If you wait a little bit and point here, hover over, then you will see the actual meaning showing up, or the actual word of the prefix showing. Same thing for milli, micro, nano, pico, and so forth. So this is just basic unit conversion. We have a quadratic module. Quadratic module has a simple version and advanced version. So the simple version, you just need to put in the three ABC values for the coefficients, and then they will solve for you the two roots, x1 and x2. If you change one of the unit for B, then C will change accordingly. So our rule right now here is B will assume to be known. It's just because otherwise, if you only give me A and C, I need to take the square root, and sometimes square root of meter, for example, is kind of awkward to get a square root of meter. So hopefully that will be meter square, for instance. Okay, so like this, velocity, acceleration, then the third one they will calculate has to be jerk, means meter per second cube. If it's SI unit, again, you can change to different prefixes. For the complete version, we give you more options. You can use the ABC input or you can input the root form or the vertex form. So once you enter, you can actually see the chart too. Right now there's nothing to see because you need to give them a boundary. So if you go from -1 to 2, then I can see the trajectory here. Now my screen right now is the ratio is not optimized for this, but imagine you can use this also on a smaller device. You can refresh your figures once you resize it. Okay, so they show you the boundaries, the lower limit and the upper limit that you choose. What is the vertex right here? Vertex is shown right here. Oh, we have set a high significant figure. So you see these answers have a lot of numbers, digits here. You can definitely change that back into more reasonable ones. Okay, like this. So you see these numbers are now more easier to be read off from our settings. Refresh this, they will make a nicer looking use of the space. So these are designed so that you can use it on the phone, supposedly, on tablets and smaller screen size. So this is a quadratic module. Similarly, we have trigonometry, solving triangle using SSA, SSS, for example. You can be, well, first of all, let's take a look at the review section too. So review section shows you the steps, the explanations to solve this problem, and we make it available for eventually for every single calculations that we do. Now, if you choose the review level to be lower, then only the most important ones will be shown. If the review level is higher to 9, that means the whole 9 yard, everything we're showing them to you. So you'll see more steps when you choose the review level to be high, or fewer steps for a low review level. Only the essential ones will be shown to you, or the most important ones will be shown to you. So this review tab or button here is what we intend to give you the explanations and the detailed steps. So most of these, if you just put in a different combination, then they will calculate this for you. Okay, you can choose this to be angles. So the idea is you just need to give me three inputs, and then we can always calculate this. And you can also find out that we'll have different ways of solving it and also different possibilities. So if I put this to 35 degrees, for example, so the two possibilities, two solutions is shown simultaneously, and also they are changing in real time. Again, you can change your sig figs and they will change instantaneously. We have vectors, you can add them, subtract them, multiply them, dot product, cross product. Now if you try to add these two vectors together, they will tell you that you cannot because one is length, the other is force, so it doesn't work that way. But nonetheless, you can multiply them together. And the results here show you that, alright, the dot product is 6 joules of energy. Force times length is joules of energy. Okay. When you look at moment of force, like the torque, that's also force times meter. So sometimes we do not know exactly what you want, but this is a compatible units. And they will tell you what is the angle in terms of degrees or radians or a number of pi's. And they will give you different components. So we also will give you the visual, what it looks like. So the gray area here, the area of parallelogram is for the cross product. And if you look at the dot product, you're looking at different projections. The cross product results are also expressed in 3 different ways: the rectangular, cylindrical, and spherical coordinates. And you can always change the number of decimals right here. Okay, so everything will change in real time. If you really want to add them together, they have to be of same dimensions. So because this one is length, then I also want a length adding to a length. So now you can add them. Okay. So the tip to tail method is the red with the blue give you the sum, but you can also look at the difference, the subtraction is actually just from the other diagonal of the parallelogram. So this nice picture shows you exactly how two vectors add or subtract. All right. Next one is a slightly different case, is still vectors addition. But a lot of times in physics, you'll find that we need to add several vectors together with different components. You can add a few more here, blank ones, but sometimes you want to enter the XY components directly. And other times you might actually only know the length of the vector is 6, and the Y component is -4. And I will still be able to figure out what are the x and the angle so that you can add them together. So these are all color coded, red, green, yellow, aquamarine. So these are the sequence. You add them together and that's the final, the resultant, the total. And the total is given on the last row. So right now, I think I have a maximum of 7 for the 7 rainbow colors, but I can add more if someone really wants to add all these different vectors together. You can change the units in real time. So again, the physical quantity itself doesn't change, it's just a representation, meaning the unit is changed. You can use degrees if you want to. Alright, so this last section that we have right now is a 1D kinematic section. So we have the kinematics equation listed here. The first two are the basic kinematics equation, and then you can derive 3 others. They are all depending on each other, they are not independent equations. The third one is conservation of energy. You look at it that way. The next one is just average velocity, and the last one is kind of rolling time backwards compared to the first one. So if you give me 3 of these 5 quantities, then we can always calculate the other 2. But when I say always, there are some exceptions. Like in this case, we actually have 2 possibilities. So if you ask what is the situation if you give me the initial velocity of 5 meters per second with the free fall acceleration 9.81 meters per second square. So these two are same direction, same positive sign, right? So you are accelerating downwards and your initial velocity is downwards. And if you cover a distance 2.5, then what happens? That's what we're asking. And when you solve it, the standard solution is given by the first scenario here. You just increase and pick up speed. The final velocity is 8.605. That's with 3 significant figures. Or 4 significant figures. My apologies. And how do we solve this? Well, you use the green equation here. And then you can use the highlighted yellow equation to calculate the time. So the time it takes is just 0.3675. But there is actually another possibility. If you started off with this velocity, you see that the time that we solve in that case is negative, meaning V2 actually happens before V1. So you started off with this negative 8.605 velocity, but you are accelerating the opposite way. So eventually you stop and then turn around, come back to this velocity 5 meters per second, and the distance that you cover that way, if you always use x2 minus x1, is still 2.5. So that's mathematically the other possibility. And we'll show you all these possible answers like this. Just like all the other interface, you can just create your own combinations. So in 3 seconds here, they will show you this is what's happening. Okay. If the figure doesn't look right, you can always use a refresh button to clean them up. So you can see that now the yellow equation is how to solve this answer, and the green equation is to solve the other answers. All right. If you need to learn how to solve this, quickly look at the review. You will see the steps it takes. I will provide better explanations as time goes on. So if you don't want to see so many steps, you can lower your review level, then only the most important ones would be showing to you. You can always print them out if you need to. So this is how to use this. Oh, but I forgot to say one thing. Remember the clipboard, earlier we have a lot of quantities saved, but somehow I restarted my session and edited the video. So now let me go back and add these back. So the scratch pad has this quantity, and the last one on the scratch pad is the velocity, the speed of sound, the speed of light c. Okay, so the clipboard quantity, you can always just use it to paste it anywhere that you want. So if I want to paste it here, use the paste button. And whoop, no, they said you cannot paste it here because it's the wrong unit. You have a velocity, you cannot paste it in time. You cannot paste it in acceleration. But yes, you can paste it in velocity. So if I want to enter this as the speed of sound, then I just paste it here. Okay. Of course, that's too fast for acceleration like this, so it doesn't make any sense. So we have to just give a reasonable velocity. But the idea is you can use the scratchpad area to do some simple bookkeeping right now, and later on we'll also put some simple calculations like adding, subtracting, multiplications on the scratchpad area that you can perform. And right now you can just paste it here. You can copy this result, this answer, into your clipboard. So now the clipboard has the new quantity. If you look at the clipboard or the scratchpad, you have all these that continue to add. So I have, well, there's a limit to the number of quantities you can save here, maybe 50 or 70, something like that. So I hope this will be helpful to your learning physics.